So now we're going to be looking at equations that have the variable underneath the radical. A radical equation occurs whenever our variable is our radicand or whenever we have a variable raised to a rational exponent. Now remember, rational exponents mean that we have a radical written in a different form. When solving a radical equation, it's important to first isolate the radical before you start getting rid of it. Now when I say get rid of, I mean we are going to make it go away by raising each side of the equation to the reciprocal power. So remember, reciprocal or reciprocal means that when I multiply a number by its reciprocal, I get 1. So let's say I'm looking at 1/2. If I multiply 1/2 by its reciprocal, which is 2 over 1, I get 1. Or 2/3, the reciprocal would be 3 over 2, because when I multiply them, I get 1. Just like solving absolute value equations, you must isolate the radical before you start to try to get rid of the radical. So we are going to first bring the 5 over. Now we need to raise each side to the reciprocal power. Now remember, square root means 1/2. So the reciprocal here is going to be 2 over 1. So I'm going to raise each side to the second power. When those exponents multiply, I'll get 1, so my radical completely goes away. Solving like we normally would. X equals 6. Now it's important that you always check your answer because you can have extraneous solutions. So I'm going to go ahead and plug that back in to check to see if it works. So I'm going to get the square root of 25 minus 5. We want to know, does that equal 0? Well, that's 5 minus 5. Well, 0 does in fact equal 0, so it works out and my solution is x equals 6. There's one minor thing that we have to remember. Now, when I used to solve equations that look like this, I would square root both sides and I would get plus or minus 4. Now the reason for that is whenever I square root here, I am raising each side to the 1/2 power. Now whenever I raise a side where my denominator is an even number, I have to take into account these positive and negative values. So this is like saying that whenever we raise each side to a power where the denominator is even, I have to treat what comes out of the radical as absolute value, which pretty much just means plus or minus. Now when it's odd, I don't have to worry about that. But anytime the denominator of the exponent that you are raising each side to is even, you must treat what's inside of the radical as an absolute value equation, which means we're going to be looking at positive and negative solutions. So the first step is always to isolate the radical. Now you may not see a radical in this problem, but this rational exponent here is a radical. So I'm going to go ahead and divide each side by the term that is out front. So I'm going to be left with x plus 1 to the 2/3 power equals 4. Now to get rid of the exponent, I'm going to raise each side to the reciprocal power. Now remember, the reciprocal here is going to be 3 over 2. So raising each side to 3 over 2. Because the denominator is 2, which is even, I'm taking a square root of each side. So that means I have to take into account positive and negative values. So when this guy multiplies, we just get 1. So we have to put him in absolute value. And then we're going to evaluate what 4 to the 3/2 is. Well, that's really the square root of 4 cubed. Now the square root of 4 cubed is just 2 cubed, which is 8. So now I need to break this guy into two small equations. Remember, absolute value means we have a positive answer, or we take what's inside and we have a negative answer. So now solving these two mini equations, x equals 7 or x equals -9. Now we must check to make sure both of these work. So you would plug them back into the original equation, you would evaluate and make sure both work. In this case, both of them do, so both of them are solutions to my equation. Now of course you can write it like -9, 7 if you want to put it in bracket form. So now we have another variable that is not underneath the radical, but we still have to isolate the radical first. So I'm going to bring the 5 over. Now we do what we normally would, which is raise each side to the reciprocal power. So the reciprocal of 1/2 is 2. Now the square root in the 2 will multiply and give me 1, so I'm just left with x plus 7 on the left-hand side. Now on the right-hand side, remember we have to square this. Now this is x plus 5 times x plus 5. Please make sure you are not making the mistake of doing x squared plus 25, because those are not equal. Okay, do not do that. These are not the same thing, so do not do that. So now distributing and combining like terms, you should get x squared plus 10x plus 25. Now solving for x, told you this stuff never goes away. Bringing the 7 over. It's set equal to 0. Now we're in luck. This guy is factorable, so we're going to go ahead and factor it. Factors of 18 that add or subtract to give me 9. Well, that is 6 and 3. Both positive. So my possible x values now are going to be -3 or -6. So now we have to plug both of these back in to make sure they work. So plugging in -3, it seems to work whenever we plug in -3. So now we have to plug in -6. Plugging in -6, we get that it does not work. So x equals -6 is not a solution. My only solution is x equals -3. Normally we only have one radical in the equation, but for this one I have two different radicals. So I still need to isolate the radical. I'm going to choose the radical that has more terms underneath. So going ahead and bringing the square root of x over. Now I'm going to raise each side to the reciprocal power, which in this case is going to be 2. Now since both of these are square roots, the reciprocal power for both is 2. Now let's say you had a problem where one was a square root, one was a cube root. So that's a 1/2 power and a 1/3 power. To get rid of those fractions, you would want to raise each side to the least common denominator of those fractions. So for 1/2 and 1/3, it would be 6. But in this case, since they're both square roots, we're going to raise the side to the second power. I get x plus 5. Now I actually have to multiply this one out. Distributing here. Square root of x times square root of x is x. Now I'm going to combine like terms. Now I'm going to start solving and isolating that radical. So I'm going to bring the x over. The x's seem to go away. Bringing the -1 over, I get 4 equals 2 times the square root of x. Isolating the radical, I get 2 equals the square root of x. So now, again, we have a simpler problem that we must solve. 2 equals the square root of x. So we raise each side to the reciprocal power, which is 2. So I get 4 equals x. Now we must check our answer. So I'm going to go ahead and plug that back in to make sure it works. So I'm going to get the square root of 9 minus the square root of 4. We want to know, does that equal 1? So that's 3 minus 2. It does in fact equal 1. So x equals 4 is my final solution. So go ahead and try these 5 problems. Make sure you're isolating the radical. Make sure you're raising each side to the reciprocal power once the radical is isolated. And also check all of your solutions because you can run into extraneous solutions.